Hi, my name is Milos and welcome to Element 14 Presents. Today we're gonna make the world's loudest Lego alarm clock that won't let you snooze in the morning. Let's go and make it. And the Lego set in question is this. This is the new NASA SLS rocket Lego set that has the whole mechanized rocket lifting up with the booster separating as well as the command module. And this mission will actually be the first mission that humans go back to the moon. With this mission, the idea is for the astronauts, the 4 astronauts in the module, to go around the moon. So it's super cool. But why this Lego set for an alarm clock? Well, because the loudest man-made object ever, if we don't count any explosions, are actually rockets. So until I give you the whole idea for the project, let's first assemble this set. And our Lego set is complete. It was an incredibly fun set to put together, and I just ripped open the box as soon as I got home, as you've probably seen in the time-lapse footage. So onto our project. The whole idea with this project is to keep this whole set as unchanged as possible because it looks really cool, but I want to actually motorize it and add some additional features. What I'm actually gonna do, I'm gonna draw out the whole plan and then we're gonna go step by step and make it into reality. To explain you the idea behind my project, I'll begin by drawing the Lego set first. On the side there is a hand crank for launching the rocket. I want to do the same thing but with a stepper motor. The set looks incredible, so I really want to keep it as unmodified as possible. So my plan is to place the electronics in a box underneath the set. On the front I want a display and some buttons. The motor will drive the same mechanism as the crank, of course, but I want to keep it hidden inside. I don't want any belts or pulleys or anything similar on the outside driving the crank. I want everything to be completely hidden from view. For the display, I want the old school look, so I will go with the LED matrix modules since they look really cool for a project like this. And the buttons on the side will be used to stop the alarm and also record sounds, but more on that part a bit later. The whole idea is with this project, when the alarm is triggered, the rocket will launch and an insanely loud sound will play. So yeah, that's the whole project, so let's go and make it. So we figure out that we need some kind of motor to spin the mechanism to lift the rocket up and down. We know we're gonna have a display, but what about sound? Having just a speaker would mean it's just a regular old alarm clock. What if we want to add something else? I really want to make it as loud as humanly possible without doing permanent damage. So I thought, what's actually loud? What's a cool handheld device? What about something like this? So yeah, the whole idea is to add a megaphone to this rocket. You can point this megaphone directly at your pillow, for example, when you're sleeping, so that you know that the rocket will wake you up. How this megaphone works actually is, and don't worry, I'll try not to blow your ears out. We can record any sound, testing 1, 2, 3, and I'll maybe have to clip the audio, but don't worry, it won't be too loud. When we press the playback music button, testing 1, 2, testing 1, 2, testing 1, 2, testing. Okay, I've maybe recorded for too short, but you get the idea. My initial idea was to order the version with the USB flash drive, and I did, but of course that didn't arrive in the box. But nevertheless, the record function will work just fine, so you can record any type of sound that you want for your alarm clock. In my case, that's gonna be the rocket sound, but you can even put David Goggins if you want to. So our next step will be to actually disassemble this and to see how can we use an Arduino to control some household appliance like this megaphone or anything else for that matter. Let's take a look at how this megaphone works. So there are 6 buttons in total. We have the power on switch, we have the shouting which just repeats what you're saying louder. We have the sound recording, we have the playback, and just volume up and down. So how this works, and generally this volume up and down, I didn't really notice any differences, maybe just set to the maximum volume. What we want to do is just toggle this switch, then we press sound recording, record our sound, press it again to stop, and then also we have the playback music, which is also just toggle. So how would we control something like this with an Arduino? Let's first disassemble this and go from there. As you can see here, we have some kind of a little PCB, the microphone. These two wires go towards the speaker that we won't pull out. I'm gonna keep this whole contraption so we can get it as loud and as directed as possible. And two wires go to the battery, which is inside here. Let's take off the PCB now. Okay, now if we take a look, here is the whole PCB, which is essentially just 6 buttons, the power jack, and we have the microphone here. So if we take a look at this, this went like this. This right here is the power switch, so when we press it, you can see that it turns on. So how do we actually go around controlling this using an Arduino? We would use some relays, and we would just connect the relays in parallel with these switches. For example, if we did this, you can see how it turned on. All I did was actually just short this switch with this pair of tweezers, and that's essentially what the relay will do as well. So if we do that, okay, it needs to be a bit shorter. It's hard when I try to film that, but yeah. You get the idea, and once I solder the wires with the relays, it will be much easier. So I will just control these 3 buttons, the power button, the record, and the playback buttons, and we'll just mount this microphone somewhere convenient so that this whole thing works. You've seen how this works inside and how we're gonna control it using a few relays. The only thing that we have to figure out still is how we're gonna actually drive this rocket with a motor. I don't want to connect the motor directly to the crank because it's gonna be a whole thing outside here. I want everything to be literally underneath the rocket. Let's take a look underneath this little hood here to see how this whole mechanism works and to see how we're gonna modify it so we can drive it with NEMA 17 stepper motor. So this is the bottom of the Lego set, and as you've seen in the previous clip, when we rotate this little crank here, the rocket goes up. I'm just gonna get it up a bit so we can open this lid, which is conveniently placed here, so you can see the mechanism. When we turn this crank, it turns this gear here, which then further turns gears here. This gear here is really cool. It just makes the cool sound when the rocket goes up. Listen now. It's just literally this jumping and hitting the surface below. It's a really cool mechanism. And there are a few more bevel gears in here, and this is the main gear that actually drives this screw. So what I want to do with this is actually attach a stepper motor like this. One option would be to attach it something like this, but I don't want the motor or anything else to be visible on the outside. So I want the motor to sit actually below the surface of this, and I actually want it to turn this gear, but I don't want to do any major modifications, any cutting, so I'll try and use as much as possible from this Lego set. So let me take it apart a bit and you'll see what I mean. I'll just use this rubber band to hold the lid up. This is the gear that actually we will be using to drive this gear here. And this is the shaft. We just need another piece from here. We're gonna take that out, and the rocket will slowly also fall. So how will this work? I already made the adapter for the stepper motor here that actually just does this. So this is how we're gonna actually couple them. Managed to find it. That it would have been bad if I actually lost this piece. So what we actually need to do is this. You can follow along. This Lego part here isn't necessary, but it's a rather nice brace. So follow along as I recall on how to actually properly do it. That would be it. So now when the gear tries to drop down, you can see this mount, it has a bit of wiggle play, but that's okay. You can see that it engages nicely, and on the bottom, if you take a look, without me breaking the set in the process, this gray piece goes a bit up, and we have the stepper motor that goes on that shaft. And that's how actually this whole thing is gonna be controlled. So that was the only mechanical part that needed figuring out without actually cutting anything off. And all of the electronics will go underneath, as you will see in one of the next clips. It's time to finalize the project, and we'll begin with the electronics. So here is the full schematics. First, let's begin with the power. So we have, this will be a battery powered device. But I also want to have an option with a barrel jack so that the device can be constantly charged and the battery is just there to keep it in check if for some reason the power goes out. So there is a power switch to turn on or off the whole device, and we will control the charging with one of the relays. So there will be a relay module, as I've already told you, for controlling all of the Megaphone stuff, and all of this will be controlled by an Arduino Uno R4 Wi-Fi. It has literally the perfect number of pins. It has Wi-Fi, it has everything we need, and it's easy to work with. Besides that, we will have a step-up converter that will step up the battery voltage to 12 volts that we will use to power the Arduino through the Win pin, and also use to drive our stepper motor in the way as you've previously seen. And we will do that through a small driver board. You will get all of the details, and you can download this schematic on Element 14 community. Besides that, we have the LED matrix display, we have the two buttons, and just the relays. The schematics are rather simple. You can add these pull-down resistors as the external or use internal ones. It's up to you. I'm gonna use the internal ones just to keep everything more clean. Now it's time for CAD, then software, and then we can finally assemble the rocket. We're in Fusion now, and we're gonna look at the CAD model. This was my first time working with a Lego set and actually modeling around it. So I began by actually modeling the base of the actual Lego set on which I want to actually build upon. So this is that base, and these are just some holes. One of them is for the actual motor shaft, and the others are just mounting holes. And from there I just designed this case. So the most important thing to get here was the placement of the motor, and this is what I double checked a few times, but it proved to be rather easy because the hole spacing on the Lego sets is 4 mm, so I got this spot on. So it's a two shelf configuration. This top shelf will hold the battery, some connectors, the boost converter, and the Arduino, as you can see here. And if we check the bottom shelf, you can see the relay module down there with the stepper motor driver, and this is the circuit from the Megaphone itself. I also added this thing here, which is the microphone, so we can record any kind of sounds we want for our alarm clock. In the front, the interface is rather simple. We have the LED matrix display, as I've already mentioned, and two buttons. One of the buttons will be used to stop the alarm, and the other one will be used when you hold it down. You can record the new sound that you wanna play when your alarm goes off. The assembly is rather simple, so there are just two parts. Well, actually there is another part, this thing here. I forgot to add a charging port and a power switch, so I modeled this separately, and this will go on a different place in the Lego set. You can see that in the picture now. As you can see, it fits rather nicely and discreetly. Okay, so we have the electronics done, we have the hardware done. The last thing to do is software, so let's figure that out and finish up this. For the software, I wanted to do something a bit different. I wanted to use one of the AI agents, and I used the Codex by ChatGPT, and I was honestly amazed. Since this was an embedded project, I did a few test scripts. So these scripts are, for example, a NEMA 17 test, just some scripts that I know will work and that I tested on their own also for the LED matrix display. And from there, I just gave it a rather large prompt describing everything that I wanted it to do, how I wanted it to behave, with the whole web UI that I wanted, which I'm really bad at programming. I just find it tedious, but this was honestly a walk in the park with this. Also fine-tuning it a bit, but literally almost no troubleshooting at all. And in the end, I ended up with this interface. It's a static IP address, so I just set it at 90. You have your some random statuses here if you want to check like your battery voltage, whether you're charging the battery or not through the relay. You can set your time zone, you can set your alarm. This is something I'm really happy I managed to integrate. This is the sign mode or display mode. This is where you have your text just going in circles round and round. You can enter your text here. You can also set your scroll speed and scroll pause between the consecutive rotations, but if you set it to 0, it will just go in circles, which is really cool. You can also adjust stuff like the display brightness, and then we go to the motor control. Here, because the rocket needs to go up and down and we don't have any encoders, we're just gonna use the steps on the stepper motor. We can calibrate it with this here. We would put it at the bottom position and slowly rise it up with these steps or custom steps. Once we get to the top, we just set that current as max. In my case, this was 1460 steps with this gearing and this stepper motor setup like this. So yeah, you can just click go to min or go to max, and it will go either to min to max. Of course, this is sensitive that you don't move the rocket without the motor being moved, because it will mess it up, and it doesn't have a real home position like your typical 3D printer. Besides that, we have the Megaphone controls and the charger controls. So yeah, ChatGPT honestly did an amazing work for this. Could have I programmed this by hand? Yeah, but it would have just taken me much longer, especially all of the web stuff, but yeah, still. For a smaller project like this turned out to be really good. And our Lego alarm clock is finally complete. It turned out really amazing. This is exactly how I imagined it, with no wires sticking out anywhere, but as you've seen through the time-lapse, it was a real hassle to get all of the wires inside. The biggest problem, and I even had to pause the video so I could do it off screen, it literally took half an hour, was to put these modules into the sockets because they're really fiddly, but I managed to do it in the end. And here we also have the Megaphone. So let's see how this works. You unfortunately won't get to experience the full blast of the Megaphone, but once this is at full volume, the only thing you can hear is pain. But let's see how this works and wrap up. Here is the finished project. The Megaphone is not connected since you see the time and I don't want to wake up everybody in the household, but I'll play you some clips at the end of the video where you can also hear the sound, but fair warning, it's rather loud, so watch out if you're wearing headphones. This is the interface that we have when we go to the static IP address. In my case, as you already seen, it's .90. So you can set up your time zone, you can set up your alarm that we're gonna check out. You can do something like Lego alarm. Let's put it into sign mode. Click save, and now you will see an animation go round and round in circles like that. There is a small pause. You can adjust the speed and the pause if we remove this and click save. Let it just update. Here it goes. Now it will just go in circles without any breaks in between. Now let's return it to normal mode. Of course, the one thing that you really want to see for sure is this going up and down. So these are the controls. You can adjust the speed and you can also do manual stepping, and in that way calibrate what's your minimum and maximum height. So currently we're at current steps is 0, which is also the minimum steps. You can set that manually through this down menu here, and you can also then go to min or max position. Let's go to the max position to see how that looks. This may be a little loud, so be careful with headphones. And the rocket is launching. The movement is actually rather smooth. There's a bit of rattle, but trust me, when the Megaphone is connected, you won't even notice it. Now, this button should also lower it down now. And it will go to its home or 0 position, that's it. It's the same number of steps up as down. So that's working. There's also the charging thing and the Megaphone controls, but as I've said, I'll play you some clips. Don't really want to play it now. You won't even be able to experience the actual pain coming from that thing. The last thing to do is let's set up an alarm. So currently the date is 3rd of February, and let's say, so that would be 12 p.m. and 49 minutes. Save. And now let's just give it a moment to see if it will react, if I set it correctly. I'll always switch up whether it's AM or PM when it comes to the 12 o'clock, of course. I'll speed it up so we don't have to just sit here in silence. While we're waiting, you can also adjust the brightness. Here now it's at 1, this is at 15, but for the camera it looks much better at 1. Yeah. Couple of seconds, and here we go. So the timer will start blinking, the rocket will start rising, and also if this was connected, there would be a lot of loud sounds. And of course, if you wanna actually turn off your alarm clock, you just press the red button and the rocket lands down. So that's it, the project is working rather great. Thanks so much for watching the video. This is one of those projects that I'm gonna keep permanently on my desk because it just looks so cool, and I can always change the software a bit, maybe put some notifications here and just update it a bit and play around with the Megaphone. If you're interested in making a similar thing, you can find all of the files available for free on Element 14 community, and if you have any comments or suggestions, please leave them down below and I'll be happy to answer. Until next time, see ya!